This is not going to be a good video. Devlogs are all the rage for some reason, so I'm doing that, but I haven't been recording any footage and I don't have a playable game. So we're starting early and we're starting late. I'm going to explain how my game's code works. So let me get a nice color. The game right now is divided into a handful of scripts. We got let's say this one is math helper. This one, the thing this is responsible for is like math. It's because is okay, this is like an incremental roguelike game, kinda like incremental roguelite deck builder is how I would describe it. And it is, I think that's the genre terms. It is a game where you are keeping a clock from reaching zero. But the clock is exponentially getting faster, and to represent that, I need very small and very large numbers. And programming languages don't like that very much normally. And I think I could probably have just bought something like some implementation off of like the internet, like off of some asset store, or just copy pasted it from GitHub or something. Um, but I didn't do that, and I made my own thing. So I have two systems of note here. Okay, we're gonna divide this into two. We got I'm just gonna start using this. We got the scientific, no, oh my god, that is huge. We got the scientific notation, and we got the array notation. Now the way that the scientific notation works is it's you got like every individual variable is an array or a list, and it has two variables. It has a float and it has an int. Now the int is the exponent. So if you were to break this down, let me just write this down. That's what this represents. So this that gets that this is the mantissa, that's what goes there. This is the exponent, that's what goes there. And then this would be expressed as, I believe, 100, because two zeros on top of the mantissa. So that's how that works. And I had to do a bunch of stupid math to get that to, or not stupid math, it's actually very simple math, to get this to work. But something that's interesting is I can't really do addition and subtraction with this implementation. I mean, I can, you could do some kind of, you can do some like exponent alignment and whatever. But you see, that is limited, because that does mean that if you were to shift the exponent, let's say you have the let's say you have 1.0, and you were to shift the exponent, or you were to want to shift the exponent or align the exponents, you might need to make one of the numbers bigger. So that means this becomes 10.0 if you're shifting exponent, or it could become 10,000.0 if, and you get the problem, right? It can just keep going. It can keep getting bigger until you get the point where float can't handle it anymore. It's too big for float. Everything breaks, and we get the same problem as before. You push it back a little bit, but you eventually get the same problem as before if the numbers you are trying to do math with are too big. But there's a cool way around this, which apparently this is just something that exists, which is like arbitrary precision notation or whatever. I'm just calling it an array notation. And the way that my array notation works is really cool. Let's say you have the number 1, 2, 3. Okay. So let's just say for some reason, whatever you're using to store the number can only hold two values. So this 3 doesn't work. But what you can do is you can break it up. So let's say we get an array and we do 1, comma, 2, comma, 3, end of the array. Now, this is able to represent bigger numbers because it's smaller numbers. That's how the engine treats it. It's just smaller numbers. But in totality, they mean something different. It may just be 1 and 2 and 3, but it means to us 123. But that does mean that you have to decode it, and it does mean that you have to have a way to do math on this that actually reflects the real values of these numbers without actually just converting back to this. Because if we convert back to this, then you're going to hit the issue here where it can only hold, I guess, 2 digits. So the way that I did it is I just have a script that goes like from the beginning to the end. Let's say we're doing some additions. Let's get a second one in here. Let's say we're doing 3, 2, 1. Okay. And then let's say we're adding these two. Well, we're going to go down the line from least significant to most significant. So let's make a new one right here. So the first column, we're going to add these two. That's going to be 4. This is, you get the idea. This is just the way that you learn to do math in like elementary school, which is cool. It works, but it does have some issues. So let's say that we're actually doing a different number here. Let's say this is a 9. Well, then suddenly we're gonna run into some issues because 3 plus 9, that is equal to 12. And that doesn't fit. That's a big number. That doesn't fit. We're not supposed to have that. That's not like you can't represent that with 1 digit. So in that case, we'll just finish this. We're gonna pass over our broken thing onto another script, and which is the normalizer script. And what the normalizer script is going to do is it's going to take this number and it's going to say, okay, this 12, we're going to start from the back. We're going to say, okay, this 12, not supposed to be here. So we're going to divide it. We're going to divide it by 10. Let me do this. We're going to divide it by 10. We're going to mod it by 10. And then the remainder is going to be 2. And then we're going to take the next place, we're going to move it up. So instead of the next one being 4, the next one is 5. And then it's 4, and then we close it off. And this is a way to fix it. That's how I have it represented. This is also elementary school math. But it's kind of confusing to write an algorithm for, you would be surprised. There's a lot of edge cases. There's a lot of things that you have to account for that you would normally just treat intuitively if you're doing elementary school math. But in this case, I don't know how to deal with it. And there's also a lot of performance concerns. You see, it is like kind of expensive to iterate over the array like this. And the way that I'm doing it, or the way that I was doing it here, from like just storing it like this, what we're doing is we're going from the back to the front. And that means that we have to append something to the front of the array every time. And that's bad because you have to reindex the array. So what I ended up doing instead is I invert it. So let's say you've got the number 100. That's a 1. Let's say you got the number 100. Well, if we were to operate on this, we would have to go from the back. So instead, the way I'm doing it is I have it as 0, 0, 1. And you're supposed to read it backwards. Now this means that we can start from the least significant to the most significant But instead of starting from the back, this means we now start from the front, and that is the much easier way to go about it. That is the much more performant way to go about it. But also you do need to like kind of differentiate whether the number is positive or negative. That is important. That's part of the array math or over here that determines whether you're adding or subtracting. So this also includes a 1 to denote that it is a positive number, and then 0, 0, 1. So this is kind of makes it more complicated because you have to keep track of the fact that there's a 1 at index 0, and that's always going to, or a 1 or a 0, because it's 0 for negative. That's always going to be there. You kind of have to keep track of it, yada yada. But that's, this is a little bonus bit because I forgot to say something. The reason that I did the scientific, or the reason I did the array is because scientific is able to do multiplication and it's able to do division, but it's not able to do subtraction and addition very easily. And the array notation lends itself very easily to addition and subtraction, but it doesn't lend itself very easily to multiplication and division. But if we could convert between the two, then we could get the best of both worlds. And that's what this is for. It's just, I just made these two notations so that I can convert between the two of them and get all 4 of these essential mathematical operations so that I can actually make my code work. That's bonus post-recording. It's a whole thing. So that's that. This is like the basis of the whole thing. But then we move over to our next script, which is state modifiers. So this is where we are actually kind of getting to something that resembles an actual game. The game has some stuff like clock seconds, for example. You have to keep track of whenever a second passes on the clock, and that will call a funny little function. I'm gonna isolate this a little bit, and I'm gonna conserve my space here. For passing for passing 1 clock second, and that's going to send a proc to charms, which is that's part of the game, is charms. But essentially what this is going to do, off of the top of my head, is it's first going to, let me think about it. We're going to take the current, hold on, I actually kind of need to go over the VA script, hold on. VA, this is the global variable script. This is probably not the optimal way to do it, but I just kind of have all of my variables in one thing. So here we got the timer duration. Here's how far the timer is along. Or here we have the amount of money the player has right now. Or here we have the amount that the player's charms are going over the speed of the clock. Or here we have the speed of a clock second, which is the unit of time that the clock ticks on, which gets progressively smaller, etc., etc. Cool. Anyway, so this like references that very heavily, right? Like these two, these two don't really interact. These two, however, they interact a lot. Anyway, and then these also interact because this is built up on top of the math here, which is relevant. Anyway, so this smod, let's do this clock second pass, for example. We are first going to figure out, or we're going to take the timer duration, and then however many clock seconds to pass have been inputted. Let me, hold on. Let's see, T is timer duration, and then P is the amount to pass. So we do T minus P, and that's of course done through this array function because both of those are stored as arrays. And then after we do that, then we need to pass a proc. I'm just gonna, what is this? There was gonna be a symbol for a proc. I don't know what it is. I'm just gonna make it like, hold on. I'm gonna make it an X. I'm gonna make, no, I'm not gonna make it an X. What am I gonna make it? I'm gonna make it an R. this doesn't, no, I'm gonna make it a P. I'm gonna change this to a C. Cool. So that sends a proc over to our funny, um, over to our funny charm, over to our funny charm script here. We'll get to that later, but that forwards a proc for however many clock seconds have passed here. And then I can't think. I'm like, oh yeah, this thing also checks for freeze. It also does like a check for freeze, which is cool. It checks before it does this. If freeze equals 0, then we do that. Because if there's freeze, then it won't do that, and instead it'll pass over to the freeze function, which will check against freeze value and then subtract however much, and then C F, it's like F minus C, which is the same thing over here, but we're subtracting from freeze. And then if F is less than 0, you pass that on back to here, whatever the remainder is. I think you get the idea. And then I also have like a stupid unit system where there's units of time that it's measuring. So it's like we're doing like an accumulated amount of, like a global amount of time. So we'll just do A for that. And then if we'll do like a check here that if A is greater than the current highest unit that's been surpassed so far, then we pass a proc for that unit being passed however many times it's been passed. It's like this just too much. I don't know. I don't know why I'm doing an explanation video for the way that my game's math works. This isn't like, this is nothing. Who's going to watch this? If there's literally anybody watching this right now, I need you to stop. Anyway, so now we have the charm object, or the proc. This isn't the proc. This is the, well, no, it's like charm slots. This is the charm slots machine. So you got like, so in here you have a list that's like your charm slots, and then we're just gonna say that it's all filled with zeros, even though I actually fill it with a string if it's empty. We don't talk about that. We don't talk about my bad decisions. But we'll say it's all empty. But if there's something that's in there, then we're gonna put in a C to stand in for the fact that there's a charm in that slot. And then what this does is every time it receives a proc, then what it'll do is it will check against the charm array, and if hold on, wait, let me move this. I don't have a room. If P in the, and then if P is in the charm slot array, if the proc type, well, I guess it would be, we're going through every charm slot and we're looking if it has a charm in it, and then if it has a charm in it, then what we're doing is we're breaking down everything in the charm, and we're saying, okay, what kind of proc does this have? And if this has like a clock second passed as a proc, that's not the way I write it, but it's shorter. If it has clock second passed as a proc, then what we do is we take that, we like write down, okay, this charm here is proccing, so we go over to our proc buffer array, and we tell it, okay, we have a proc here that goes off one time for this given charm, and then we do that for however many procs there are in one frame, and then we're going to come back to that in a minute, because the next script we're going to talk about is our clock script. This is what actually drives the game, and calls everything and what have you. Now the clock script is very reliant on the math helper script, and additionally, as you might suspect, it is very reliant on the state modifier script. Because that's what contains the clock second pass function. And the reason it's here is because I kind of want to have a philosophy, or have like a design wherein all of the functions that modify the game state are kept in one little box. So it's like easy to look through, and it's kind of smooths over the development process, because if there's any particular change to a game state that I want to handle a different way, then I can just come in and I can write it here, instead of having to go hunt down across all the like a billion different scripts that are eventually going to be for every instance of that game state changing, to figure out, okay, how do I do it? How do I make it do this new thing? And it would be like a different implementation for every instance. It wouldn't be good. Anyway, so every frame, we take the total clock second duration, which is C, and then we compare it against delta. Now, this is the amount of time that has surpassed in one frame. Now, if C is equal to delta, then what we do is we divide, I think delta divided by C equals the amount of seconds that have passed in this one frame, and then we take that. And by the way, this is more complicated than I'm making it out to be, because there's a bunch of garbage that I have to do to make sure that it's in the formats that I made earlier, and not just in normal math, because if it's in normal math and you hit unit problems, and so on and so forth and what have you. And this is really, this one script is where most of the development time went. I hate this thing. But anyway, this then calls, this then goes and calls that function over there. I'm actually going to leave that line because it's funny. It goes and calls that function over there with that number. And then, so this happens every frame, which is cool. So this is one of the things that happens every frame. Every frame, it will also accelerate the clock, and it will also enforce the timer cap. So if we're adding time to the timer, then it will go and like call some function again over here that enforces the timer cap and makes sure that the amount that the time on the timer is below the timer cap. And then the timer cap function, what that's going to do is that's going to report back to here to tell you the excess, and the excess is important because that's going to be used both as a tooltip you can read, but also it's going to be used to dictate a visual effect on the timer that tells you how much you are beating it by, which is how you are going to gauge how well your build is performing and how imminent your demise is, which is cool. That's useful. Anyway, and this also does the charm procs. Specifically, what it does is it calls the proc buffer. It like finally goes through the proc buffer. So you go back down to here and you tell the script, okay, take this proc buffer, and then what you're gonna do is for you like, because every charm object has a function call, so you're going to call the charms function, which is going to be the subject of the next thing, which is the charm or not the chart. This is like the item reference script, which is cool. So what the item reference script is the data dump. It just has a bunch of information about all the charms, and then it has a bunch of like functions for every charm, like for what every charm does individually, and then those functions tie back into Math Helper and State Modifier to do what they actually do. And these get, these get called by the charm slot, like charm runner function here, which I'm gonna put in a box. It runs the charms, and I have this delayed to the end of the frame, because if this happens just whenever the prot goes off, that kind of like it creates some weird order of operations concerns, and I don't like that. Yeah, I think there are technically more scripts, but they're irrelevant. So we're going to actually just ignore these, and that's the game. That's the whole game. That's everything I've made in the last like 4 months. That's all of it. You don't need to know anymore. This is all there ever will be. I'm not making the game anymore. I quit. You will never see anything from me ever again. Goodbye.